Hi, I'm TJWalker of TJWalker and Associates, and I teach the Principles of Web Handling and Principles of Winding classes for seminars for engineers. The technology I like to share with people is that of handling paper, film, and foil and other thinner materials through rollers and complicated web-based machinery. The topics that I address are the properties of the material and what makes one web different from another, like its stiffness or its friction coefficient or other properties. And then you get right into tensioning of how do you control the tension of the process. And this is partly picking the right tension for your web, as well as understanding how tension is created from different devices. And in complicated equipment, you'll have multiple zones, and so understanding how do you look at equipment and tell when the tension is going from one zone to another. More important almost than that is to understand the tension variations that a process creates. That the cross-width tension is not uniform. The tension going roller to roller to roller is not uniform. And understanding these variations in machine direction and the cross-web direction helps understanding problems you run into, whether it's problems from bad web that doesn't carry tension well because it's baggy, or rollers that are misaligned, or other sources of problems. Once you understand tension control, we want to understand a little bit more about the rollers that create it, so understanding how drive rollers work, how idler rollers work, what their options are, different surfaces, different bearings, different diameters to avoid deflection, and then the techniques to make sure your equipment's well aligned. So just like a car needs good alignment between front and back axles, rollers, the multiple hundreds of rollers in your process need to be aligned to each other. Once you cover webs and tensioning and roller properties, we do a little bit of discussion about the specifics of nipped rollers, where you're taking two rollers and pressing them together and creating a high pressure nip point. This can be done to pull the web and create friction, but more so it's done in the value-added processes of printing and coating and calendaring and embossing and winding to get pressure, to exclude air, to squeegee liquids, to emboss solids. And so in understanding nipping is really where a lot of the money is in web handling. That getting the web up to the nip point safely is of course important, but to get in and through the nip point and have the nip do what you want to do is highly critical in these processes. And that's something we want to explain to people, how they get their nips uniform, what type of rubber to use, how much rubber, and what creates variations in those processes. And then we move on to one of the really big topics of web handling, which is wrinkling and wrinkle waste, where in handling the material, it doesn't stay flat, but it gathers either in spans or on rollers, and it buckles and forms creases that are undesirable to the end customer. In the wrinkling, we do two things. We try to explain to people why webs wrinkle, going over the fundamentals of what makes the web go to the left or to the right, and why it complains about that, and say what causes the wrinkle, can we stop the cause? Or alternately, we say, the cause is inherent to my process, what special roller design could I do that would pull the web out or spread the web or have anti-wrinkle properties? That also includes the topics of left-right motion and web guiding, of keeping the web stable and in position and aligning it to your equipment. So those are sort of group topics of the lateral control of guiding, spreading, and wrinkling. And then you move into the last topic, which is moving from the web handling principles into the winding principles of how do you wind up the product to make a good roll, how do you ensure that roll has quality that customers will want to buy. When the customer unwinds the web and inspects the web that comes out of the wound roll, is the quality going to be there that they want? And this really gets divided into at least three different main areas in talking about winding. One is just this physics of the act of taking the web and winding it up on a core, layer after layer, sometimes tens of thousands of layers in a wound roll, and doing that successfully under tension, in position, without wrinkles, controlling the air, controlling the tightness of the roll, and just imagine what the web feels like as it does that. And then you can say, okay, we're done, we've built this structure. A wound roll that you built could be like a multi-story skyscraper with many levels to it. And how did you build that structurally? Will it have the properties you need to then go unwind it, or transport it, or store it? Or will it block on itself when you try to unwind it, it won't come apart? Will there be buckles in the roll that you've made? Will there be impressions between the layers? So lots of things. Or is the side of the roll flush and aligned? So many things that are the ideal wound roll and the ideal quality of the web as it comes out of the wound roll. So that discussion about winding, what we want winding to be like, and roll quality, what we want roll quality to be like, isn't done in space, it's done with good equipment design. And the equipment that does it, you call a winder, and winders, there's not one design. Just like cars, there's many different features to cars you might buy. In winders, there's lots of different options of how do you drive it, how do you control the touchdown, how do you start a new roll and end another roll, can you wind 5 rolls at the same time or 50 rolls at the same time? Many questions on winder design, and how do you even go to a supplier and see, here's the features I want, what do you have? Is this a feature worth paying for? And so getting a winder that will do what you want to make the quality roll you want is important. So that in the nutshell, when you cover webs, tensioning, rollers, nipping, lateral control, winding, that puts it all together and gets you the sub-technologies. And of course, what you want to do is figure out how you can apply that to problem solving. You have production, you're making money, you're making waste, you try to reduce the waste so you can make some more money. And that's what we hope principles of web handling and winding gives you, is a competitive advantage to make a successful product with low waste.